Welcome to Section 2, Lesson 6. In the previous lesson, we learned the keyword dictionary that maps English words to algebraic operators, and we practiced 2 clean translations using that dictionary. Today, we focus on the dirty cases. The sentences where the dictionary alone is not enough because English itself is ambiguous, where word order plays subtle tricks, where the phrase looks innocent but the standard reading produces the wrong algebra. These trap patterns show up on every standardized test, in every word problem set, and in every applied math course you will ever take. So building a small library of templates that handle them automatically is the most efficient use of practice time you can make at this stage of the algebra course. First idea on the board. Most translation errors are not algebra errors at all. They are English reading errors that produce the wrong algebraic structure before the algebra even begins. The student knows perfectly well how to solve 2n plus 5 equals 17, but if the original sentence translated incorrectly to 2n minus 5 equals 17 because of an order flip, the solution will be wrong no matter how clean the algebra is. Today's lesson is therefore mostly about reading English carefully, with the algebraic translation being the byproduct of that careful reading. Second idea. The order flip family is the single biggest source of translation errors. The phrases less than, subtracted from, fewer than, and reduced from all reverse the natural left to right order on the page. 5 less than a number is the variable minus 5, not 5 minus the variable. The phrase 10 subtracted from a quantity is the quantity minus 10, not 10 minus the quantity. The phrase how much less than is also a reversal. Memorize the reversal phrases and treat them as a permanent red flag pattern that triggers an order check every single time you see them. Third idea. The next 3 trap families are the ambiguous use of the word of, the percent phrasing that hides a multiplication, and the multiplier direction in twice as many as patterns. The word of often signals multiplication. Half of x means 1/2 times x, 20% of y means 0.2 times y. The percent traps add the wrinkle that the percent symbol must be converted to a decimal before any arithmetic happens. The twice as many as trap is direction sensitive. If A has twice as many as B, then A equals 2B, not B equals 2A. Today, we work 2 full word problems that feature these traps and build the templates so the trap patterns become automatic recognition the next time you see them in any context. There are 4 trap families that account for almost every translation mistake students make in beginning algebra. Each family has a clear pattern, and once you can recognize the pattern in a sentence, you can apply the correct template automatically without having to reason from first principles every time. Trap family 1 is the order flip family. The phrases less than, subtracted from, fewer than, and reduced from all reverse the natural left to right order on the page. 5 less than a number translates as the variable minus 5. A number subtracted from 10 translates as 10 minus the variable. The reversal is unintuitive at first because it does not match how the words are spoken in everyday English, so the safest practice is to underline these phrases the moment you see them and write the reversed expression deliberately. Trap family 2 is the ambiguous of. The word of in math word problems usually signals multiplication, but the surrounding context determines what is being multiplied by what. Half of x is 1/2 times x. 20% of y is 0.2 times y. The phrase the average of a and b is the sum of a and b divided by 2, which uses of in a different sense. Read the surrounding context carefully to decide what kind of multiplication is being signaled. Trap family 3 is percent phrasing. Whenever a sentence contains a percent, that percent must be converted to a decimal before any arithmetic happens. 20% becomes 0.2. 150% becomes 1.5. The percent symbol itself is just notation for division by 100. Many students forget the conversion and treat 20% as the number 20, which produces wildly wrong answers. Always convert immediately upon translating before any other operation touches the percent value. Trap family 4 is the twice as many as direction. If sentence says A has twice as many items as B, then A equals to B, not B equals to A. The bigger quantity is the one being described, and the multiplier sits in front of the smaller quantity. Same trick with 3 times as many, 4 times as old, half as much, and similar comparison patterns. Always identify which side of the comparison is the bigger quantity and place the multiplier on the smaller quantity. Reading the equation back into English is again the safest verification step, because a wrong direction makes the read back say something different from the original sentence. Here is the first worked example. The sentence Sarah is 4 years older than twice Tom's age. Translate this sentence into an algebraic expression that gives Sarah's age in terms of Tom's age. The trap here is the phrase older than, which acts like a more than reversal combined with the multiplier in twice that needs to attach to Tom's age, not Sarah's. Step 1. Identify the unknowns and decide which one becomes the variable. Tom's age is the simpler quantity because Sarah's is described in terms of it. Let t equal Tom's age. Then Sarah's age will be expressed as an algebraic expression in t with no second variable needed. Step 2. Recognize the keyword operators in the sentence. The phrase twice means multiplication by 2, so twice Tom's age becomes 2t. The phrase older than acts like more than, signaling addition with the older quantity on the left and the offset on the right. 4 years older than 2t becomes 2t plus 4. Step 3. Assemble the expression for Sarah's age. 2t plus 4 is the algebraic representation. Notice the multiplier 2 attaches to Tom's age t, not to anything related to Sarah, because the sentence said twice Tom's age, not twice Sarah's age. Reading the wrong direction is the most common error on age comparison problems and is exactly the trap family 4 pattern. Step 4. Verify the translation by reading the expression back into English. 2t plus 4 reads as twice Tom's age plus 4. Compare against the original 4 years older than twice Tom's age. Same relationship, same multiplier direction, same offset. Translation confirmed. So Sarah's age, in terms of Tom's age t, equals 2t plus 4. The big lesson from this example is that age problems and other comparison problems require careful attention to which side of the comparison is the bigger quantity. The multiplier always attaches to the smaller side, and the reversal phrases like more than and older than then add the offset on top of the multiplied chunk. The verification read aloud catches direction errors immediately, so always include it. As a bonus check, if you were also told that Tom is 12 years old, you could now substitute t equals 12 and compute Sarah's age as 2 times 12 plus 4 equals 28. Completing the full evaluate after translate workflow that combines today's translation skill with the evaluation skill from lesson 4. Here is the second worked example. The sentence twice the difference of x and 5 is 8 less than 3x. Translate this sentence into an algebraic equation. The traps here are the ambiguous of inside difference of the word is meaning equals at the center of the sentence, and the order flip phrase 8 less than at the end, which reverses to give a subtraction with x leading. Step 1. Parse the left side of the sentence carefully. The phrase the difference of x and 5 means x minus 5 with x leading because it appears first. Wrap that subtraction in parentheses because the next operator outside will multiply the entire chunk. The chunk so far is parentheses x minus 5 parentheses. Step 2. Apply the twice multiplier to the whole chunk. Twice the chunk parentheses x minus 5 parentheses becomes 2 times parentheses x minus 5 parentheses. The parentheses are essential because they hold the chunk together, so the multiplier hits both terms. The left side of the eventual equation is now 2 times parentheses x minus 5 parentheses. Step 3. Parse the right side. The phrase 8 less than 3x is an order flip pattern. Less than reverses, so the algebra is 3x minus 8, with 3x leading and 8 subtracted from it. The right side of the equation is now 3x minus 8, and the word is at the center of the sentence becomes the equals sign joining the two sides. Step 4. Assemble the full equation. 2 times parenthesis x minus 5 parenthesis equals 3x minus 8. Notice the parentheses on the left and the order on the right are exactly what the trap families warned about, the difference of needed grouping, the less than needed reversal. Both traps were handled cleanly because we processed each piece deliberately rather than rushing. So the translated equation is 2 times parentheses minus 5 parentheses equals 3x minus 8. The big lesson from this example is that 2 or 3 traps can stack inside a single sentence, and each one needs its own deliberate handling. The difference of trap requires grouping with parentheses. The less than trap requires reversal of operand order. The is trap requires the equals sign and not subtraction. Stacking them inside one sentence is exactly what standardized tests and harder textbook problems do to separate fluent translators from guessing students. Today's deliberate template approach handles stacked traps without breaking a sweat. As a bonus check, you could now distribute the 2 on the left side to get 2x minus 10 equals 3x minus 8, then solve to find x equals negative 2, completing the full translate, then solve workflow that the rest of the algebra course will train extensively. 3 order, flip patterns that catch every algebra student during their first weeks of word problem work. Each one reverses the natural left to right reading and produces a wrong algebraic expression if translated literally word by word. First pattern, less than. 5 less than a number is the variable minus 5, not 5 minus the variable. The phrase less than reverses the order the smaller quantity in the phrase appears as the second operand of the subtraction, not the first. Memorize the reversal as a permanent association so the moment you see less than you write the larger quantity first and the smaller one second. The same reversal applies to fewer than, reduced by, and decreased by in similar contexts. Subtracted from. 10 subtracted from x is x minus 10, not 10 minus x. The word from in this phrase tells you which quantity is the base of the subtraction, and the base appears as the first operand. Watch for the from preposition specifically. It is the linguistic marker that flips the order. Same pattern for taken from and removed from in some textbook phrasings. Older than and younger than for age problems. If Sarah is 4 years older than Tom, then Sarah equals Tom plus 4. The bigger person, Sarah, sits on the left side of the equation. The smaller person plus the offset sits on the right. Reading the algebra back as Sarah equals Tom plus 4 immediately matches the original English. Reading it as Sarah plus 4 equals Tom or as 4 equals Tom plus Sarah would not match and would alert you to a translation error before you got further into the problem. Translation traps are not academic. The order flip patterns and ambiguous of phrases appear constantly in real-world documents, contracts, and standardized tests, often costing significant points or money when read incorrectly. 4 broad domains below. On the S8, GRE, GMAT, and most state algebra exams, the test writers deliberately use order, flip phrases like less than and subtracted from in word problems precisely because they know most students translate them literally word by word and produce a wrong answer. Recognizing the trap pattern instantly and applying the reversal template is the single highest value test preparation move you can make for any of these exams. Practice 10 or 20 problems containing the trap phrases until the reversal becomes automatic, and your test scores will improve noticeably. In contracts and legal documents, refund clauses, penalty calculations, and escrow rules are full of phrases like reduced by, subtracted from, less than, and fewer than. A small business owner who misreads a refund formula by translating literally can lose real money on every transaction until they catch the error. Lawyers and accountants who translate fluently spot ambiguities and gaming opportunities in contracts that less careful readers miss entirely. In engineering and software requirements documents, comparison phrases translate into mathematical inequalities. The pump must move at least 300 liters per minute is one inequality direction. The pump must move no more than 300 liters per minute is the opposite. Misreading the comparison direction during requirements interpretation produces test cases that pass when they should fail or vice versa, which is one of the most expensive bug categories in software engineering. Even in everyday product labels and recipes, phrases like reduced by 30%, 4 fewer servings, and half of the original quantity contain the same trap patterns. Misreading any of them in the kitchen or at the hardware store produces wrong measurements and ruined dinners or wasted materials. The translation skill is in continuous use, and the trap library is as valuable in everyday life as it is on the estate or in legal work. 3 things to take with you from this lesson today. Translation traps account for nearly all word problem errors in beginning algebra, and a small library of trap handling templates lets you avoid almost every one of them automatically. First, the order flip phrases less than subtracted from fewer than and reduced by always reverse the natural left to right reading on the page. 5 less than a number is the variable minus 5, not 5 minus the variable. Treat the reversal phrases as permanent red flags that trigger a deliberate write down of the expression in the correct order. Underline the phrase, write the larger quantity first, then write the offset second. Build the habit into reflex over a few dozen practice problems, and you will never miss a flip again. Second, the word of in math word problems almost always signals multiplication. Half of x is 1/2 times x, 20% of y is 0.2 times y, 3/4 of the total is 0.75 times the total. Convert percent symbols to decimals immediately upon translation, before any arithmetic happens. The off trap is less notorious than the order flip trap, but trips up plenty of students on percent heavy financial and statistical word problems, especially on the GRE and GMAT, where percent problems are common. Third, the verification step of reading every translated expression back into English is the single most valuable habit in all of Word to algebra translation. It costs 5 seconds, it catches almost every translation error, and it works for every trap family covered today. Build it into your standard word problem workflow as a non-negotiable final step before you start solving the algebra. Coming up next, the lesson called Expression Templates, where we collect the most common algebraic structures that recur across word problems, give them template names, and use those templates to translate even faster on familiar problem types. Templates plus today's trap library together give you fluent translation across almost every algebra word problem you are likely to encounter for the rest of this course and beyond.